Hi everyone, and welcome to training part 2 of CMonster's official training. This section will cover enterprise and MSSP Kubernetes management. The topics that will be covered is Docker versus Kubernetes, the terminology use, Kubernetes management tools and processes, and notes and consideration. To understand the differences between Docker and Kubernetes, one has to look at the purpose that they were created for. Docker is in itself a containerization platform. It is intended to create singular containers to provide microservices for specific functions or needs. Kubernetes, on the other hand, is a containerization orchestrator which controls, manages, and assigns resourcing and or scaling for the containers. So you would use Kubernetes to increase the number of containers you have providing a specific function, which you could then put behind a load balancer to provide a much higher throughput capable service. Further understanding requires that one looks at the terminology use. Docker containers are based on images that have been created to provide microservices. These images are either manually created on your Docker implementation, or you can create them locally and upload them to some kind of repository where you can Docker pull them from. Kubernetes has pods that consist of one or more of these containers based on images. A pod can be a collection of images. It can also be a collection of shared storage, network, and specification configurations, etc. And the naming standard behind this is based on a pod of whales, so it's a collective term. The reason for that being is Kubernetes was designed with scaling in mind, so you would cluster or combine small pods of various functionality so that you could extend the quality of service that you provide with any of the microservices running on the cluster. To manage the CMonster cluster or Kubernetes cluster, there are certain requirements that need to be met. SSH, or a shell console that has access to the Kubernetes cluster, is needed, as well as kubectl, the application, and the Kubernetes config, also named the kubectl. The SSH shell, you would need to establish a connection, a SSH connection to the Bastion host in cases where it's a hosted application, or you can shell console directly to the Kubernetes cluster from something like WSL for Windows or your local terminal on a Mac, etc. kubectl is the binary or application that is used to manage the solution. There are numerous functions or functionality that you can utilize with this command, and a further breakdown of these individual items can be seen at the listed URLs. To use the kubectl, one needs to export the variables that is contained within the kubeconfig file. This file contains all relevant details, including authentication, etc., to connect to the Kubernetes cluster so that administration can take place. To begin the management process, one has to either connect to the SSH host that one will be using, such as the Bastion host, or establishing a terminal session that can be used for this process. The first step is to export the kubeconfig file, in this case demo kubeconfig, and you utilize kubectl to perform the relevant administrative function. To demonstrate this, you can see that there's a shell there. You can see that the demo kubeconfig is there. So essentially what you would do is export that config. Once the kubeconfig has been exported, commands such as kubectl get all namespaces -o wide can be run. This will give a very large listing of all the services that is associated with this cluster. Bearing in mind that should this be a remote cluster, sometimes the communication can take a while to take place, as it establishes a secure connection for the command first. As you can see, there is quite a number of items being displayed. Most of these are pre-configured with our solution and requires no further input from you. The ones that are important are the ones that's under the namespace cmonster. You can see the namespace column there. The name of the individual pods are here. The status is there, that they're ready or not, and the full status is listed there, the number of times they've been restarted. These are either indicators that they've been restarted as part of cron jobs or scheduled items or services that require refreshing, etc. So these do not necessarily indicate failures. The age of the containers or pods are also demonstrated here, as well as the IP addresses that they are used to be accessed with. As could be seen in that shell window, it shows absolutely all configuration items for the cluster. So in cases of troubleshooting, you may want to access all the services and all the pods as part of the solution, but for most cases this will not be necessary. If one wanted to see all the nodes that are included in the cluster, one would simply run that command demonstrated. So we can just paste that there. This will give a listing of all the nodes. In this case, there is only a single node servicing the solution, but in most enterprise or MSSP editions, there will be at least 5 or 6, probably more depending on the load that will be generated. It will give you the name of the node. It will tell you its status, the role, the age, and the current version of it. To look at the specific items that would be relevant to everyday administration or utilization of the host for maintenance purposes, one would look at these commands. The first command, kubectl get pods, all namespaces wide, will give you a listing of all the pods for all the various components of the cluster. This can be necessary in cases of wider spread issues such as networking, etc., but also for the most part that would not be necessary. An example of the output for that would be the following. It literally just lists all the pods with the same columns as previously shown. If one were to look at the next one, kubectl -n cmonster means that we've defined the namespace to use as cmonster, and we want all the pods for that, and we want the wide. You can remove the O wide, which will just give you a listing of the pods with basic information. Wide provides the additional information such as the IP addresses, etc., which is quite helpful. To demonstrate this, we can just run the command, and you can see now that it just has the name. It doesn't have the namespace column because it is limited to a single namespace, and it provides all the relevant data for the other containers. Should one decide to filter the outputs so that one gets to the specific pod or container that one wants, one can simply pipe that information to grep. I prefer to use the -i, which means it's case insensitive, and we can use wazoo as an example. That will bring back just the pods or containers that is specific to wazoo, and then you can see the output for that. The next part, of course, is to actually access the shell console on one of these containers or pods. To do so, we simply run kubectl -n cmonster for the namespace, exec space -it, and then the pod name that was discovered with the previous result, followed by the shell that is relevant to the container. Majority of the containers are Alpine Linux based, which means that you would replace bash with ash. Bash is of course the short for born again shell, and ash is the Alpine shell. We can demonstrate this. And there you go. There you are now shelled into the actual container that is delivering the Wazoo service. You can perform any functions that you used to do. So here's -e or -ef, whichever, and you can see what's running on there. To exit out of this container, you just press Ctrl+D. That'll drop you back to your previous shell and release the shell on the actual container. To copy files from the container or to the container, the examples on the screen can be used. It is, however, very advisable to be extremely careful when using these, as they could be destructive in nature. So only run copy commands on a production environment once they have been tested in a local environment or in a test environment, unless they have been pre-proven or pre-tested by the CMonster team and have been provided to you as such. Copy processes can replace files, can replace folders and the entire contents, which could essentially means that a container stops functioning. It's relatively simple to recover it, however it could cause an outage in production environments, which could interfere with your ITIL-based or compliance-based processes and could have an impact on your operating. If you would like to see which of your nodes in a multi-node configuration is the busiest, you can use the kubectl top nodes. As we know, this demonstration edition only has one, but running the command will still give you an output. It will show you the CPU cores and the CPU percentage, etc. Bear in mind that this instance runs on AWS, so the CPU core count doesn't reflect accurately. The processor utilization is also to be considered because of the scaling functions in AWS itself. When you run this as part of your VMware infrastructure, etc., or bare metal, then that would reflect accurately. This session is a very basic introduction to the management of Kubernetes clusters, nodes, and pods for the CMonster solution. Additional functions of kubectl command can be reviewed in the links provided earlier in the session. For customization of the Kubernetes cluster, it is recommended to involve the CMonster team to validate changes and to prevent potential outages. CMonster team is also available on a consulting basis in case there are bottlenecks on resource configurations, etc., to facilitate with troubleshooting and to make appropriate changes to the cluster to facilitate getting the system performing optimally. With that, I hope you've enjoyed this session, and please let us know if there are any considerations you would like us to add in future training for this.